Hello everyone. In basic control system, this is the second lecture. In this lecture, I am going to discuss about what is control problem. So as I written here, so for a given plant, okay, plant, sensor, actuator, we design the controller, okay. We design a controller such that output Y behaves as per desired specifications. In control system, like in lecture 1, I have explained, like we have plant, actuator, combined we call it as process, and we have controller, and we measure the output using some sensor. So for the given data of plant, actuator, sensor, we design the controller. Here it will be in feedback form. We design the controller such that the output Y behave as per desired specification. Okay, so this is what we highlight as control problem. The objectives of control system, there are four objectives of control system. One is stabilization, second regulation, third tracking, fourth robustness. Now what is stabilization? When we design the controller, when we design the controller, the signals like so we have here error signal. Let me use different pen. We have here input U and output Y. These signals doesn't blow off. When we design the controller, nothing blows off, nothing goes out of bound. Means the signals, these signals are in stable mode, nothing goes out of bound. This is known as stabilization. Regulation. Mm, Based on our desired output, we give input as a reference. In the presence of disturbance, this output will change, but we want to maintain output as R, Y equal to R. So to maintain operating point, to maintain a desired operating point even in the presence of disturbance, even in the presence of disturbance. This is known as regulation. Tracking. As explained in lecture 1, we want output angle theta naught equal to theta I. Means output should follow the reference, follow the reference as closely as possible. This is known as tracking. Robustness. What is robustness? For actual system, we take the mathematical model of plant, we take mathematical model of sensor, we take mathematical model of actuator. For this mathematical model, we design the controller. So how robust the designed controller is, that is nothing but robustness. How robust your designed controller. These are the main four objectives of control system: stabilization, regulation, tracking, robustness. Here I have given transient response specifications, steady state specifications, steady state response specification. Generally, as explained in lecture 1, suppose we want to maintain output, suppose we have given input as 30 degrees. The general response will be either this one or this one. So from here until it reaches steady state, this is known as transient response. Once it reaches steady state, this is known as steady state response specifications. So what are the objectives in transient? One of the objective is should try to rise as fast as possible to reach R. Output Y should try to rise as fast as possible. So it need to rise as fast as possible. When it rises, there should not be high overshoot and undershoot. So these are the overshoot and undershoot. It shouldn't be very high and it should not oscillate for long. Before reaching steady state, the oscillations, the response generators, that oscillation should be very less. So these are the main three transient response specifications. Now, what is steady state response specifications? Means we want output Y should be very close to R after a considerable amount of time. Means after the transient dies out, we want output y should be very close to r. This is known as transient state response specification. So these are the things I want to highlight in lecture 2. Thanks for joining. Thank you.